Good morning, everyone. Today we're going to be talking about equations with variables on both sides. This video is going to be quite longer than the others that you have probably seen, but that's because there's only going to be one video this week, and we're kind of doing all of this stuff that you need to know for Friday. All right. So what you will need to submit today is your notes from today. So that's all you have to submit at the end. But you will need a pencil and paper. So if you don't have it, go ahead, you pause this video and go get some. Here are some photos from this past couple days with the snow. My son was out there playing. And then here's a little thing. My daughter, she just turned 7 months. Can you guys believe that 7 months ago was when I left and gave birth to Eva? But I'm back. So, all right. How are you going to take successful notes? While you're watching this video, make sure you're pausing and rewinding as necessary. Don't write everything down. Just write down the examples or the steps to solve, the stuff that you can look at your notes and say, okay, this is what I'm going to do. And so on your quiz on Friday, you're looking at your notes and saying, oh yeah, I remember how to do it because I wrote down these notes from the video. And then rewatch the video as necessary. So you can skip around to examples that you want to watch again. You don't have to watch it all from get-go, like from the very beginning to the very end. I don't mind if you just like, I'm going to ignore this part and I'm going to ignore this part. Oh, this joke of the day, I don't really need to know it. All right. So on your note page, I do want you to write your name at the top of the page, just like this shows on the screen. And then the title is Multi-Step Equations with Variables on Both Sides of the Equal Sign. Okay, as we talked about last week, this week's going to be look a little different. We're doing a video lesson at the beginning, so on Monday, submit your notes, and Wednesday, we're going to come together. We're going to do some examples together. This is the expectation for Wednesdays that you have already watched the video for Monday. And then you're coming with questions. And then Friday, we have an assessment about the stuff that we've learned. Okay, let's get to it. Yes, this slide is very busy. Our objective is I can solve multi-step equations that have variables on both sides of the equal sign, and I can determine if the equation has infinite solutions, one solution, or no solution. We are talking about Indiana Standards 8 AF1 and 8 AF2 today, so this is what we're covering, is the 8th grade standards. Okay, these are the steps. Step 1, you're going to distribute everything. Get rid of those parentheses. Step 2, combine all like terms. Step 3, you're going to move the variables from one side to the other side using adding and subtracting. Step 3, move all the constants to the other side using adding and subtracting. And then the last step, step 5, is solve the one-step equation using multiplying and dividing, the inverse relationships. Pause this video, write down your notes. Okay, let's go ahead and do this example. Screen. So, do I have anything that I need to distribute? Yes, I do. So, don't know where to put the video, so it's out of the way. All right, so I need to distribute this 3. And when I'm distributing, I am multiplying the outside term by the inside term. So 3 times 3n gives me 3n. 3 times -2 gives me -6. And minus 2. -2 times 1 is 2. Negative 2. Positive 2. Positive 2 times 8n gives me 16n. All right. Next step says combine all the like terms. So in this case, I have this -6 and -2 that I need to combine. So I'm going to do 3n, and -6 minus 2 is -8 because they're the same sign. Okay, step 3, I need to move all of the variables to one side of the equation. So I can either move the 3n or I can move the 16n. I'm going to move the smaller number. So I'm going to move minus, I'm going to take the 3 minus 3n. I'm going to move my n's to that side of the equal sign. So these cancel out over here. Notice I am moving the n as well. So I'm taking the whole term. So over here I have negative 8 equals 2 plus 16n minus 3n. That gives me 13n. And now I'm going to move all of the constants. If you don't remember what constants are, they are terms that don't have a variable. They don't change. So I'm going to move this 2 to this side of the equal sign. So I want my constants on one side and my variables on the other side. So how do I do that? The inverse of a positive 2 is a minus 2. So over here, these cancel out. I'm left with 13n equals negative 8 minus 2. They're the same sign. That means that I get negative 10 over here. Then I have to get rid of this 13. So I just did this one, and I need to solve the one-step equation. I'm going to divide by 13 on both sides. So n is equal to negative 10 over 13. And that's my final answer. Okay. If you need to, pause, rewind, watch again, but we're going to do another example. All right, same deal. I need to distribute everything. So I'm going to take my negative 2, I'm going to distribute those. Negative 2 times x gives me negative 2x. Negative 2 times positive 8 gives me negative 16 plus 4. Sorry, guys. I don't know why it does that. It switches to the pointer instead of the pen. And so then I need to make sure I catch it. All right, over here I do have a negative to distribute. See, since that negative is, we have to apply it to the parentheses. So I have minus 8 negative because there's an invisible 1. If you guys don't remember, there's a 1 right here that we're distributing. Okay? And then the negative 1 times positive 2x gives me negative 2x. All right, so I have some terms to combine. I'm going to use a different color. I have negative 16 and positive 4 on this side of the equal sign, and then on this side of the equal sign, on the other, I have my terms with x's that I need to combine. So over here, I have negative 2x, and then I have to do negative 16 plus 4. Those are two different signs, so I need to subtract and keep the sign of the larger absolute value. So negative 16 plus 4 is negative 12. And then on this side, I have my x's to combine. So 5x minus 2x is 3x minus 8. Okay, so I've just done step 1 and step 2, and now I need to do step 3, which is moving the variables. So I can either move the negative 2x, or I can move the 3x. Since this negative 2 is negative, I'm going to move it to this side. Okay, so let's clear up. Right. So I'm going to add 2x because the opposite of a negative is a positive. So I'm adding 2x to both sides. And if it helps, draw that line down the equal sign. These cancel out over here. I'm left with negative 12 equals 5x minus 8. And now I have to move my negative 8 to the other side with the negative 12. So I get the constants on the same side. So I'm going to do positive 8 because it's a negative. I'm adding positive 8. These cancel out. I'm left with 5x equals negative 12 plus 8. They're same, different signs, so I subtract, and I get negative 4. Now I'm going to get the x by itself by dividing by 5, and I get negative 4/5 equals x as my answer. Okay, this next example, I want you guys to pause this video and try it yourself. right, welcome back from pausing. Let's go ahead and solve this. I'm not going to explain my steps as much because you should have already done this. So make sure I have the pen on. I'm going to distribute, get rid of the parentheses on both sides. So I'm bringing down my 4x plus 3x plus 9, and then 2x minus 10. Don't forget you are only distributing what's inside of the parentheses, and you have to stop at the end of the parentheses. So I'm not multiplying my 2 times my 4. Now I'm going to combine like terms. So here I have 7x plus 9 on this side. And over here I have 2x and, sorry guys, and negative 6. Now I'm going to move my variables. So I'm going to subtract 2x. So I'm using adding and subtracting to move the whole term with the variable. These cancel out. Over here I'm left with 5x plus 9 equals negative 6. And now I need to subtract 9 from both sides. I have 5x equals what? Negative 15. Divide by 5 to get rid of the 5. And I get x is equal to negative 15 over 5. But I can actually divide that. So my answer is going to be negative 5. Oh, not negative 5. Negative 3. Negative 3. All right. Let's go ahead and do another. Okay, so we need to distribute. Why don't you guys go ahead and pause the video and try it and then check your answer with me. All right, welcome back. So I'm distributing. I get 6x minus 12 is equal to 6x minus 12. I don't have anything to combine, so I can go ahead and start moving my variable over. Minus 6x minus 6x. Okay, so that cancels out. Oh, wait, minus 6x. 6x minus 6x, well, that gives me 0. Ooh, oh, did not mean to. I don't know how to get back. Oh, no. I'm sorry, guys. I don't know how to. Oh, my word. I don't know how to. There we go. Oh, technology. All right. And you guys are probably like, I don't know why you're complaining about technology. I'm an expert. You're just an old person that doesn't know how to use the technology, right? And I don't. Oh, there it goes. Okay. There we go. Oh. All right. So these cancel out, and now I'm left with negative 12 equals negative 12. But I can keep on. This is weird, right? Okay. So negative 12. Negative 12 equals negative 12. That's correct, right? I'm going to add 12 to both sides. That cancels out. I get 0 equals 0. Is that what you guys got? Or did you get x is equal to x? Okay, so this one is a unique situation. So over here, I did it a little differently. I got rid of the constants first, and then I did it. So this is a unique situation. It's a situation called infinite situation. So besides the examples that you've written down, also write down this. So it says, if the variables on both sides of the equal sign and the constants on both sides of the equal sign are equal or the same, there are infinite solutions. So it can be, there's lots of different solutions. So just make sure that you know that you didn't mess up. That is correct, even though it looks weird. The answer to this is that there are infinite solutions. Okay? All right, let's try another example. Okay, so here I do need to combine my like terms. I don't have anything to distribute, but I'm going to combine these right here. So over here I have 3x plus 11 equals 3x plus 8, right? How did I get the 3x? Well, I added the 2x plus x. All right, so here they're not the equal on both sides, but I am going to use my variable here to get rid of the 3x. These cancel out, and I'm left with 11 equals 8. What? It's so confusing, Miss Me. That's what I did. And you are not wrong. This is correct. But what we have to say is that there are no solutions to this. So the answer is actually no solutions. So this is also a unique situation. If the variables on both sides of the equal sign equal each other, but the constants on both sides do not, the equation has no solution. So for example, we had 8 equals 11. A number equals a different number. That can't be true. 8 does not equal 11. If I have 8 apples, I don't have 11 apples, right? So in your notes, make sure you write this down. Here's a little cheat sheet. No solutions. You can get 3 equals 5. These are examples of equations with no possible solutions. All right, let's do another example. Bet you're wondering what I did this time. And I don't remember. I did it all, but I don't remember this one. All right, so I'm going to subtract the 2x. Get rid of my variables first. So minus 2x. So over here, they cancel out. And I have 20 equals 2x plus 20. And then I can get rid of the 20 over here. Okay, so 20 minus 20, that's 0 equals 2x. All right, I can divide by 2. Divide by 2. 0 divided by 2. I know this is funky, but 0 divided by 2, you can do that. Gives you 0. So x is equal to 0, right? Does it look a little weird? This is your answer. 0 is an answer. It is a number, guys. So there's only one solution to this, right? There is only one solution. Remember, 0 is a number too. All right. So, oh wait, sorry. You guys do not have to do the IXL. I am sorry. I forgot to erase that. Don't do this. But here's a short little guide to help you remember. One solution, you will always have only one number and the variable on one side and one number. Infinite solutions, you will have the same thing on both sides of the equal sign. And then no solution is you will have a statement that's not true. So 3 does not equal 5. It's something like, remember if you were on the live conference, what Mason did with Mr. Sheets's joke, or like riddle, is what he only drew one line and he made it so that they weren't equal. Okay, so that's a no solutions. All right, so joke of the day. Okay, last one, guys. What's 5q plus 10? Sorry, what's 5q plus 5q? And you guys should know this, right? Variables. And then all the students are saying 10q. And the teacher says, you're welcome. And you know me. This is totally me, right? I crack me up. Get it? 10q sounds like thank you. I crack myself up. All right. What do you have to do today? Is you're going to submit a picture of your notes. Make sure your name's on top so that I know that you submitted it. You're going to submit it under lesson 10 assignment, Monday, 4/20/2020. And then next time on Wednesday, you're going to come together on our conference at 9 a.m. I'd like to see more of you. We have about half of the people showing up. Actually, a third. I'd like to see more people, please. And then Friday, we're going to have a quiz that you're going to be able to do 3 times. And I will put that up after our conference so that you can try it after the conference. Please email me if you have any questions. And we can set up a one-on-one if you need it. All right. So that is it for today's for today's lesson. Hopefully you guys are ready to talk with me on Wednesday. Bye, guys.